about the properties of exponents. We don't really need reminding because we just reviewed them. But here's a chart that has all of our properties of exponents, and I found this on the internet, but I'm giving credit. See? There we go. That's where I found it.
Cred.
All right.
Street cred.
That's right.
What is that emoji up there in the corner?
This is a tool I had to upload so that when you guys play Kahoot and you like to add emojis to your names, they actually show up on the screen.
Oh, really?
If I didn't add that tool, then you guys couldn't use your phone emojis when you're playing. Anyway, all right. Remember our properties. Product of powers. When you're multiplying like bases, what do you do with the exponents? Add them. Quotient. When you divide like bases, you subtract the exponents. If we have a power that's being raised to a power to a power, what do? We multiply. Now these are our three big ones, which is why I have them boxed. These are the most important for what we're doing now. But we know all these others are also true. If we have a product raised to a power of a product, then each part of the product gets raised to that power. Same for a quotient. We also know that if we have a negative exponent, it means reciprocal. We know that anything to the first power is just what we started with. And any number raised to the 0 power, except 0 to the 0, any other non-zero quantity raised to the 0 power is 1. Now, the ones that are key for us right now are these three. Because logarithms are exponents. When we solve the logarithm, we're finding the exponent. So those rules for exponents are critical. When we multiplied like bases, don't write yet. I want you just listening. I'm going to give you a writing moment. When we multiply like bases, what did we do with those exponents? Added them. So this is one of our properties. This product right here, this multiplication, can be rewritten as addition because the logarithm is the exponent. What do I do with the exponents when I multiply? I add them. Okay, here's division. What did I do with the exponents when I divided like bases? Subtract them. So I can rewrite this as subtraction. What do I do with the exponents when I raise a power to a power? I multiply them. So this power can come out in front and become multiplication. And all of this has to do with the fact that the logarithm is an exponent, and we're following those rules. Now write.
I don't have any paper. It is unfortunate. If you have paper, you have some paper. I would just
work out for us?
I just found these big ones on here.
I'll come back to it in a minute. All right, this is in your workbook, but guys, we don't really need our workbooks. This is supposed to be the word simplify. I know. I'll change it a little bit. Simplify. It's supposed to be simplify. All right, so these problems are straight out of the workbook, but we don't need our workbooks. We can just look at the problems. All right, we're going to take those properties we just looked at, and we're going to apply them here. If this means this, does this mean this? Yes. And so we can go back and forth. And so what we're going to do today is we're going to look at condensing, writing it as a single log, and then we'll also look at expanding, because they're both ways are helpful at times. We're going to prove that this is true real quick. When did we add the exponents? We add the exponents when we were doing what with the basis? Multiplication. So this we can write as multiplication. Okay, and what is, I'll tell you. 9 times 27 is 243. Does anybody know what power? Or can we raise 3 to a power and get 243?
Yes.
It is, this one is 5. 5. Now, let's do a check step real quick. What if I had simplified here and here? What power do I raise 3 to get 9? 2. What power do I raise 3 to get 27?
3.
Is 2 plus 3 equal to 5?
Yes.
Ooh.
Can we do that? That way's faster?
Okay, you can't always do that. And if the directions say write as a single log, we have to go here first.
True.
Okay? So, go here first, and then double check it the other way with number 2. You divide that next.
It's out.
Equals 7. Yep.
Okay, for this one, it's 8 times 16. And so as a single log, this would be 128, correct?
Yes.
Yeah.
And we raised 2 to the 7th power. Well, it would have been easier if we were going straight for the 7. It would have been easier to say, well, 3 plus 4 is 7. Yeah, I'm with you. It would be easier to do it that way. But sometimes they don't simplify.
Oh, no.
Sometimes they don't. Like this one. I don't know what power to raise 10 to get 80. Now, do I even need that 10 written there? No. So I'm going to not write it because I'm a little lazy. And this is 80 times 125, which
10,000.
is 10,000. Okay, so this is written as a single log, but now this does simplify, doesn't it?
Yep.
What power can I raise 10 to get 10,000? The 4th. Okay, so even though it didn't simplify here and it didn't simplify there, together it made something pretty. All right, you try number 4.
What the? Don't do number 5.
Okay, so we got 8 times 27 here, which is 216. Is that right? All right, and this is written as a single log. Does this logarithm simplify?
Yes.
Yep.
Yes,
Three.
to 3. Sometimes it will, sometimes it won't. We might end up with like log base 4 of 20, and we can't do anything.
So wait, the answer is just 3, nothing else?
This is written as a single log, and this is simplified. So, yeah, the final answer would be 3. Okay, now, these, do we have the same base?
Yes.
That's critical, because if we had like 2 to the 3rd times 5 squared, if we don't have the same base, we can't do anything, can we? So here we have the same base, so we can combine these. So this just gets written as multiplication. And that's it. There's nothing else we can do. It doesn't simplify. Not any further. Does that make sense?
Yes.
Okay. Now, this one has a little more.
I think I just discovered a mathematical break.
Awesome. You can share that with me in just a moment. All right. So we have a product here, and we have a difference. And we're to combine these as a single log. So what can I do with this multiplying out in front here? When I did a power to a power, I multiplied, right?
Yes.
So that becomes a squared. And now, how can I rewrite this difference when I want to write it as a single log? Division. So it becomes log base 3 of a squared over 4.
That's math, Joe. I like it.
Math.
I like the adding ones better.
Just wait until we add E.
Why would it be 2, or how can it become a square if it's 2 times that?
Okay, our rules with exponents. When we raise a power to a power, we multiply those exponents, right? So if I have a logarithm, the answer to a logarithm is an exponent. So if I'm multiplying these, this is actually an exponent.
Okay.
Can you give us another one? Let's see if this works.
You want more?
Yeah, one of the number things. Like no exponents, any variables.
No, it's variable time.
Tell her your theory, Doug, see if you're right.
Alright, so you see see number 4, right?
Okay.
So the base of that is 6. Or not the base, but yeah.
Yeah, the base is 6.
So then if you do 6 to the 1.5, you get 14.69693846. And then if you do the square root of 216, which was the thing at the end, you get 14.69693846. So I want to see if it works for any other numbers.
What?
This is the same.
What?
Alright, nobody's sure what you're talking about, but here's number 7.
Oh boy, Doug.
You're doing exactly what we're doing. You're
I just
adding a
asked for
square
a
root.
difference and he said it doesn't.
All things go
That's your calculator.
That's as far as I went.
What is that?
That just means the battery on my Moby is shot. It's so old, it doesn't hold a charge, so it's continually resetting. So I'll plug her up.
No, it just sounded like it was coming from over there.
Okay, so this becomes log base 2 of 80 divided by 10,
Yes.
which is log base 2 of 8, which is 3.
Yeah.
Okay, you try number 8, and then we'll have a fun one with number 9.
What? No.
We like to have fun.
It works, Miss Wooley.
It's if you like divide the exponent
If you
in
divide,
half.
yeah, the exponent, which was 3, in half, and then put it as the
That
exponent to the base, then it will equal the same thing as the square root of the exponent in the answer.
no of the answer.
I have to write it out.
I don't feel like this is a breakthrough.
Like if you took
No.
since
No, no.
6 cubed is 216. If you divided 3
It's
in
that-
half
Well, I mean, it's
and you did 6
not-
to the 1.5, that answer is the same if you do the square root of 6 cubed.
Oh, yeah. Doug, that's not a breakthrough.
I think it is, so it's not common knowledge.
The 3/2 power, which is 1.5, is the same as, remember the bottom numbers are root, the top numbers are power.
No, I didn't do that though.
It's the same thing.
It's the exact same thing.
I didn't put it up to the third.
Okay. Alright, log of 4,000 divided by 40 is log of 100, which is 2. Did you get it?
Yeah.
Alright, now this one, it's just more. So if we were asked to write this as a single log, what would it look like?
Why don't there's log 2 in it?
Very good.
If it was a what?
Okay, and then A gets divided by B and gets multiplied times C. But the B is to the third,
thought it would have been to the negative.
and can we write it like this?
No.
You're really bored. But
Or if you're trying to be accurate.
well, why would it be negative? Because it is.
It's a -3 and you're moving that over. Or do you do
It's minus.
But how do you know
3.
the difference between a minus and a negative if it's in front of the 3
Why did Franny just not make
There's no difference. Because if I just wrote this,
you move it over?
and I thought this was the exponent, it moves it to the bottom.
Hey, well, I want to read cursive. Let's see what this says.
Isn't that where it ended up? She's so happy. I see.
I can see the happiness.
The joy. Alright. Oh! Speaking of joy, let's go the other way. This says expand.
I got you. I got this.
I'm not even going to teach it. You just try those.
I got it.
You don't need me.
No.
Mr. O'Brien did for me.
I've got 2 scores of Sperry's.
Alright.
Sorry, I was just thinking out loud.
I can do this, Miss Wilson.
I know you can.
I don't think I can.
Are we expanding this? Did I get it right? Is that a Z?
Yes.
It is a Z. And number 10?
Should we go ahead and do both?
Sure.
Both?
I like them.
So weird. That's fine.
Sweet.
You got
I think so.
What you got? So let's check out.
I think so. Alright, y'all are fast. So this becomes log, base B, with a 2 in front, an X there.
That's a good question.
Does it matter what order you put
It doesn't. These two could be in either spot.
That's gotta get your mind out of the socket.
Okay? This would be log base 3 of 4 plus 3 log base 3 of A minus 2 log base 3 of B.
I don't like how the L's look like ones, but I always think it's like 31 and 21. I'm like,
Ooh, sorry.
Yeah, that's okay.
Yeah. Okay, let's move on.
What can you do backwards?
It does. They're like 10G.
I really like the next kind of problems. I'm excited to go do them.
Next time, you mean tomorrow?
No, like the next slide.
Oh.
We're not even up to 19.
It's not going that far. I make copies of the slides. That way, like, watch this. Next class period, this is what I have to do to make everything go away. And now I'm ready. But I only can do that because I made a copy of the slide. My original work.
Oh, that's the fun stuff.
Yes, this is the fun stuff. All right, we skipped a problem. We're going to go to 13. All right, log base 4 of 4 to the 6 with no calculator is simple.
With 2 calculators.
With no calculator. Because this exponent can come out in front and be rewritten as multiplication. And then you just simply ask yourself, oh, what power should I raise 4 to get 4? Oh, the first. And 6 times 1 is 6. So simple. You try.
No, I did.
Number 14. That's just for Ben.
What?
Okay, what can you do with the exponent? You can rewrite it as multiplication. So this exponent comes out in front. Times log base 5 of 5.
I just get exponents.
What power do you raise 5 to get 5? 1. So the answer is x minus 5. That's the answer.
Wait, hold on. Is the answer just the exponent?
Sometimes.
They're gonna make that. What the?
Alright,
15, yeah, I hate you.
so number 15 is different, and some of you are scared. You should never be scared of math. Alright,
the healthy fear of school.
these were log form. This one's not. This one's exponential form. I have a base raised to an exponent. Does everybody see this base raised to that exponent? Usually we have that equaling an answer, don't we? Okay? So usually when we have a base raised to an exponent, we have it equaling an answer. None of us have a clue what to do, so we switch forms. Whenever you get stuck, we switch forms. So we're going to switch to log form. So it becomes log, what's my base? 7 of my answer equals my exponent.
Oh.
Okay, what is the only way this log base 7 can equal this log base 7? Is if A equals 30. That's my answer.
No.
So it is just
I give up.
It's compulsive.
What?
That's what I just said.
Yes, Ben?
How did you get the log 7a? Wouldn't it just be like 7a? Because a is the
Okay, Ben, what I did was I switched forms. Did you watch that happen?
Yes.
Okay, let's use a different letter. Maybe it'll make us happier. So this is an base raised to an exponent equals an answer. You can make your answer x. Doesn't matter. And then if we switch forms, it becomes log. What is the base over here? 7 of the answer part equals the exponent part.
Oh.
So the only way these two statements can be equivalent, we have the same base, is if this part equals this part. Therefore, the answer is 30.
I get that.
I'm never
Thank you
going to
for
do
that.
any work ever again because this is all equaling the exponent.
I chose some of the next ones to prove you wrong. Okay, maybe 16 doesn't prove you wrong, but the next one does.
Yeah, 16 is not.
16 does not prove you wrong.
Yeah,
These are problem numbers I picked out of your workbook. That's why they don't go in order. All right. Doug thinks the answer to this one is 1, and he's right.
Good job.
Okay? But now let's prove why. A base raised to an exponent equals an answer part. We switch forms. Log base 12 of A equals log base 12 of 1. The only way these can be equal is if A equals 1. Now, so Doug wants to make 4 the answer to number 18. But it can't be. And Ben is correct. It is 8.
I told him that answer.
Okay. So, this is 3. This was 12. This was 12. This was 7. This was 7. This was 5. This is 5. This is 4. This is 4. This is 3 and this is not. But we could rewrite 9 as 3 squared. Which makes it 8. And then 8 times log base 3 of 3 is 8.
So you still don't have to do any work.
Or,
No.
ooh, 4 comes out in front here. So we get 4 times log base 3 of 9. Ooh, what power do I raise 3 to get 9? 2. And 4 times 2 is 8. Or,
No.
do you want another one?
Yes.
Nothing's 10. Nothing's 10. Log base 3 of 9 to the 4th equals x.
What?
So 3 to the x equals 9 to the 4th. So 3 to the x equals 3 squared to the 4th. So 3 to the x equals 3 to the 8th. So x is 8. It doesn't matter.
So you still don't have to do any work.
It's all 8.
Yeah.
All right. Homework's on the couch.